Alright, for this language, where we have an even number of zeros and an odd number of ones, we're going to illustrate how we can use one state for each kind of string that we have in the language. And so we'll have one state for each of the possible combinations of evenness and oddness on zeros and ones. To help illustrate that, we'll label each of these states as well with something other than just Q0, Q1, Q2, and Q3. So my first state is going to represent the situation where I have an even number of zeros and an even number of ones. State Q1 then will represent the state or the situation where we have an odd number of zeros, even number of ones. Q3 will be where both the number of zeros and the number of ones is odd. And Q2 will be where I have an even number of zeros, odd number of ones. Alright, so based on that, it should be obvious where my initial and final states are. Clearly Q2 has to be final because it's an even number of zeros, odd number of ones, which is what we want. And if we think about an empty string, it would have 0 zeros and 0 ones in it, both even. So this will be my initial state. Now what we have to do is just figure out the transitions. Well, and that's easy because each time I read a 0 or a 1, it changes the evenness or oddness of the string, and so I move to the appropriate state. So for instance, if I start in Q0 and read a 0, then I don't have an even number of zeros anymore, I have an odd number of zeros, so we'll move to here. If I start here with an even number of ones and read a 1, then I have an odd number of ones. Notice also that these sort of have reciprocals. If I have an even number, an odd number of zeros and I read a 0, I'm back to an even number of zeros. And likewise, if I have an odd number of ones and read a 1, I'm back to an even number of ones. Now we'll have a similar thing going on this side of the machine. A 1 takes me from an even number of ones to an odd number of ones. And if I have an odd number of ones and read a 1, I'm back to even. And down here, same thing. Zeros, though, take me back and forth between the odd and even states of zeros. Alright, now if we run this, we'll try it for a string that's in the language. And let's do 4 zeros with 3 ones distributed like this. And there's no particular reason for that. It's just a string that happens to be in the language. If we run it, I start out in even and even. I'm going to read a 0. Takes me to an odd number of zeros, even number of ones, back or over to odd and odd because I have one of each. Now temporarily I'm in the accepting state because I've seen an even number of zeros but an odd number of ones so far. But of course I'm not complete yet. Back to the initial state. Q1, Q3, Q2, and I accept the string. So it is always the case that if you can figure out the equivalence classes of the strings in your language, you'll have one state for each one of those classes. And in this particular case, I had 4 equivalence classes, 4 states in my DFA to accept that language.